Welcome to the DIY Honda Garage channel. This presentation is focused on DTC P16E2, which signifies a PGM-FI-ACG LIN communication error for Honda CRV models from 2017 to 2022. DTC stands for Diagnostic Trouble Code, which is employed by the vehicle's onboard diagnostic system to identify faults in its operations. The code suggests communication issues within the LIN, or local interconnect network, which is crucial for controlling various components such as the alternator and battery sensors. The specific components affected here include the alternator, battery sensor, and the Powertrain Control Module, PCM, all essential for the vehicle's performance and electrical systems. Proper communication between these components is necessary for the vehicle to function optimally and to ensure that electrical demands are met. Understanding how these systems interact is essential for effective troubleshooting and resolution of this DTC. The DTC P16E2 indicates a communication issue pertaining to the PGM-FI-ACG LIN network, implicating several key components. The alternator is responsible for charging the vehicle's battery and powering electrical systems when the engine is running. The Powertrain Control Module, or PCM, manages engine functions and communicates with other systems to ensure efficient vehicle operation. In this instance, if there is a breakdown in communication between the alternator and the PCM via the LIN, it can lead to performance issues or even electrical failures. The connections between these devices must be intact, as any loose terminal or damage could directly result in this error code being triggered. Improper communication might yield various problems, as these components need to relay information effectively to maintain the electrical integrity of the vehicle. Possible causes for the DTC P16E2 revolve around several key areas. One common issue is a loose terminal on the alternator, specifically the ACG plus B terminal, which can cause disrupted communication between the alternator and the PCM. This scenario leads to the storage of DTC P16E2 as the system detects irregularities in the signals being sent or received. Faulty LIN wiring may also contribute to this error. The LIN wiring is integral for sensor communication, and if it is damaged or shorted, it can impair system performance. Lastly, a complete loss of communication with the PCM can also result in this code being stored, indicating that troubleshooting needs to focus on both the alternator connections and the integrity of the LIN circuit. When DTC P16E2 is present, several symptoms may manifest, indicating underlying issues within the vehicle's electrical system. The most immediate symptom is usually the illumination of the check engine light on the dashboard, alerting the driver to potential problems. Additionally, drivers may experience various electrical system malfunctions, such as failure of accessories or reduced battery charge, pointing toward alternator problems. Drivers might also report poor engine performance due to the PCM's compromised ability to manage engine functions effectively in the face of communication errors. These symptoms serve as warnings, prompting the need for diagnostic procedures to investigate the underlying causes of the DTC. To begin troubleshooting DTC P16E2, the initial step is to turn the vehicle to the on mode without starting the engine. By entering this mode, systems are activated, allowing you to gather data and perform diagnostics effectively. The next step involves using the HDS, or Honda Diagnostic System, to clear the existing DTC codes. This process ensures that you are starting from a clean slate before further tests are conducted. After clearing the DTCs, you turn the vehicle back to the off position and then switch it to on mode again after a mandatory wait of 10 seconds. The final action in this step involves checking for any pending or confirmed DTCs via the HDS to determine if P16E2 reappears, indicating a persistent issue. In this second step of troubleshooting for DTC P16E2, the focus shifts to checking for any pending or confirmed DTCs using the Honda diagnostic system. After rerunning the diagnostic scan, it is essential to look for any new codes, particularly DTC P16E3, which denotes a PGM-FI battery sensor LIN communication error. If DTC P16E3 is indicated, it signals a potential issue that might impact the ability to diagnose P16E2 efficiently. Following this, a decision is made based on whether DTC P16E3 is present or absent, directing the technician to the next troubleshooting steps as outlined in the diagnostic guide. Continuing with the troubleshooting for DTC P16E2, the next step involves another scan for any pending DTCs using the HDS. Particularly, you will look for DTC P16E8, which is associated with a PGM-FI shutter grille LIN communication error. This is significant because any additional communication errors listed will help narrow down the focus for repairs. If DTC P16E8 appears, it suggests further complications within the system wiring or connections that warrant special attention. Determining the presence or absence of DTC P16E8 will guide the follow-up actions in the troubleshooting process to ensure a systematic approach to diagnosing the issue. In the fourth troubleshooting step for DTC P16E2, the next area of focus involves checking again for any pending DTCs, specifically monitoring for P16E5. This DTC code references a LIN communication error involving the PCM's DC-DC converter. Finding a confirmed presence of this error indicates another layer of potential communication failure, which could directly reflect the problems being experienced with P16E2. As such, determining whether P16E5 shows up will dictate whether further diagnostics are warranted, or if steps need to be taken to specifically address the PCM communication pathways. Step 5 in troubleshooting DTC P16E2 focuses on determining the area of failure, particularly with the LIN line or battery sensor. Begin by turning the vehicle to the off or lock mode before proceeding to disconnect the alternator's 1P connector for testing. Following this, you will measure the resistance between the test points using a multimeter, ensuring that the test condition is with the vehicle in the off mode and the alternator disconnected. Test point 1 will involve the female terminal number 1 of the alternator connector, while test point 2 must connect to body ground. The results from this test will dictate the next steps in troubleshooting based on whether the resistance found is 1 megaohm or more. For the sixth step in resolving DTC P16E2, you will need to address the possibility of shorted wires affecting the LIN communication. This is initiated by jumping the SCS or short circuit switch line using the HDS and allowing a minimum waiting period of 1 minute. After successfully jumping the SCS, the next action is to test for continuity between the alternator's 1P connector terminal and body ground. This test will involve progressively disconnecting each relevant connector one at a time, including the PCM connector A, 12-volt battery sensor 2P, and others as specified in the diagnostic instructions. If at least one disconnect results in discontinuity, it shows that the LIN wire is in good condition, while failure to find discontinuity suggests that shorts exist within the LIN circuit, requiring further repair. Step 7 in addressing DTC P16E2 involves a determination of failure between the alternator and the battery sensor. Begin by reconnecting the alternator's 1P connector to restore circuit integrity. Then, you will need to disconnect the 12-volt battery sensor's 2P connector for testing purposes. Just as with previous steps, measure the resistance while ensuring the test is conducted in the off or lock mode with the battery sensor disconnected. Test point 1 will involve female terminal number 2 of the battery sensor connector, and test point 2 will measure resistance to body ground. If the resistance reads 1 megaohm or more, it indicates that the circuit is complete, allowing you to move on to the next step. The 8th troubleshooting step for DTC P16E2 will require you to conduct an open wire check on the LIN communication pathway. Much like previous procedures, begin by jumping the SCS line with the HDS and waiting more than 1 minute. After this setup, you'll need to disconnect both the alternator 1P and PCM connector A. Following these disconnections, measure the resistance between the assigned test points with the vehicle in the off mode. Test point 1 will reference the alternator's female terminal number 1, and test point 2 will connect to PCM connector A's number 10 terminal. A reading of 1 ohms or less indicates that the LIN wire is functioning as intended. A higher measurement means an open circuit needs repair. Step 9 continues the search for failure areas concerning the DTC P16E2, focusing on the LIN communication pathway. Start by confirming the vehicle is in the off mode before disconnecting the alternator's 1P connector again. Next, measure resistance between the test points using the connectors disassembled. The measurement will occur at the same test points as previous steps: the female terminal 1 of the alternator connector and body ground. Results of 1 megaohm or more will guide you to the next step, whereas lower values will indicate additional issues needing rectification. In the 10th step within the DTC P16E2 troubleshooting process, the focus shifts back to checking for shorted wires, which could contribute to communication issues. This step begins similarly, with jumping the SCS line via the HDS and allowing necessary time for accurate testing. The next objective is to verify continuity between the alternator's connector and body ground, while systematically disconnecting associated connectors one at a time. This method determines whether the LIN wire holds up. If checking continuity reveals a break when one of the connectors is disconnected, it confirms that the wire is intact. If continuity fails throughout, more extensive diagnostics will be required to pinpoint and repair short-circuit locations in the LIN circuit. Step 11 brings the focus back to assessing issues linked to the alternator, which may be contributing to the DTC P16E2 findings. Following reconnection of the alternator 1P connector, you will need to proceed by disconnecting the shutter grill's upper and lower 4P connectors. Resistance measurement is performed between test points, defined by choosing a terminal from the shutter grill connector and comparing it with body ground. Resistance of 1 megaohm or higher shall lead toward the next troubleshooting actions, while results indicating otherwise will result in diagnoses pointing primarily toward an issue with the alternator in need of replacement. In Step 12 of the Troubleshooting Guide for DTC P16E2, another open wire check is necessitated to ensure thorough diagnosis. The gathering process, once again, includes jumping the SCS line with HDS, giving it necessary time to stabilize. Subsequently, you'll disconnect both the alternator's 1P and the shutter grill connector, measuring resistance between previously specified test points. Again, measuring this in off mode allows for checking the integrity of the LIN circuit effectively. If the resistance measures to be 1.0 ohms or below, the LIN wire is operational. Otherwise, a diagnostics and repair request for an opened wire in the system between the alternator and A10 of the PCM becomes crucial. Moving on to step 13 in diagnosing the issue surrounding DTC P16E2, you again check the possible failure area while measuring the alternator connector. Start again with the vehicle in the off mode. Disconnect the alternator's 1P connector for validation, following up to reassess resistance between designated test points. The testing matches previous routines, aiming to gather values associated with body ground conditions. Achieving a result of 1 megaohm or greater will proceed to additional troubleshooting directions, while failing to meet these values will indicate the necessary assessment steps leading directly back toward the alternator. Step 14 continues with checking for potential shorted wires associated with the LIN bat sensor, LIN line, in relation to DTC P16E2. As per previous routines, initiate the process by jumping the SCS line with the HDS, again allowing for an effective waiting period. After this initiation, you will want to examine continuity by disconnecting selected connectors. Similarly to previous troubleshooting occasions, successful disconnection that results in a change in continuity signals established LIN wire integrity. Otherwise, the troubleshooting suggests that more elaborate repairs are necessary to address wiring issues that originate between the alternator, PCM, and associated connectors. In the 15th troubleshooting step, refocus on the alternator connector yet again to determine any failures associated with LIN bat sensor communications. First, ensure the alternator's 1P connector is reconnected before taking down the DC-DC converter connector A, allowing for an accurate resistance check. Measurement will occur in the same method you've employed, confirming voltage at body ground through the testing points. Resistance of 1 megaohm or more will lead toward the remaining necessary diagnostic efforts. However, if resistance is lower than this parameter, it typically suggests the need for a recommendation toward alternator replacement. The 16th step resumes the open wire check for DTC P16E2, aimed at confirming the integrity of the LIN bat sensor LIN line. Start by following the procedures to jump the SCS line with the HDS, while giving it more than a minute for connections to harmonize. After this, the alternator and DC-DC converter connectors are disconnected to conduct resistance measurements across available test points, allowing for full details on circuit integrity. Achieving a measurement of 1.0 ohm or less signifies intact wiring. The alternative results will initiate a comprehensive analysis leading to repairs made to an open line noted within the LIN pathways monitored. The final troubleshooting step for DTC P16E2 entails a thorough probe for open wires within the LIN communication pathway. This action involves returning the vehicle to the off mode again, then executing the SCS line jump as previously conducted. Disconnect both the alternator's 1P connector and PCM connector A to validate resistance measurements amid these connections. Testing once more with the selected parameters, particularly focusing on the alternator's female terminal number 1 against the PCM's number 10 terminal, will allow adequate assessments. If resistance registers at 1.0 ohms or less, it indicates successful communication pathways. Higher values necessitate critical repairs on any identified open wire areas between the alternator and the PCM. Once repairs associated with DTC P16E2 have been executed, confirming their effectiveness is essential before finalizing the service. Start by checking all connections and components to ensure that no loose terminals remain at either the alternator or the PCM. Following visual and physical inspections, proceed by using the HDS to clear all previously recorded DTCs. After clearing these codes, The next stage is comprehensive vehicle performance testing, seeing to it that the vehicle operates without triggering DTC P16E2 again. Successful testing assures that the repairs have fully resolved the issues present and that communication within the LIN network is functioning seamlessly. Preventive maintenance plays a pivotal role in avoiding future occurrences of DTC P16E2 and ensuring the vehicle operates efficiently. Regular inspections of the alternator and battery sensor connections allow for the identification of potential loose terminals or corroded contacts before they escalate into larger issues. It's advisable to proactively monitor the electrical systems in the vehicle, particularly focusing on the LIN communication network to confirm all components interact harmoniously. Furthermore, keeping the vehicle's battery and electrical system in good repair can mitigate risks of further communication errors between critical components. By integrating these regular maintenance practices, vehicle reliability can be substantially improved, minimizing both downtime and repair costs. In conclusion, DTC P16E2 denotes critical communication errors within the vehicle's PGM-FI-ACG LIN network, leading to potential disruptions affecting battery charging and performance. It is essential to identify the key components involved, including the alternator, battery sensor, and PCM, to understand the broader implications of this issue. Comprehensive and stepwise troubleshooting is required to precisely diagnose and resolve the underlying communication failures. Successfully addressing these areas can enhance vehicle reliability, operational efficiency, and reduce the likelihood of future DTC events. Adopting preventive maintenance measures further safeguards against similar occurrences, assisting in the long-term health of the vehicle's electrical systems. Please like and subscribe to the channel. See you next time.